Hi, this is Miss Logan. Today I will be talking about full projectile motion. This is part 2 of our projectile motions flipped lessons. Full projectile problems are a little bit different than what we have been doing before. For the last week, we've been working on problems where we only have velocity in our x direction. Now we're going to have two velocities. We're going to have one in the x and one in the y. So basically just be replacing v0 in the y with a number. So some reminders. Our horizontal motion is going to remain constant. However, our vertical motion will be changing, just like it did for our vertical problems. So as the object is going up through a projectile, our vertical velocity will decrease all the way to the top where v0 or v final is 0. Then as we go down, our vertical velocity will increase. So vertically launched projectiles will always be at an angle. So the problem will say something like a ball was launched at 30 degrees at 3 miles per hour. What we need to do first is draw out our triangle. So we'd have 30 degrees in here, 3 meters per second here. This is when we are using cosine and sine. We use cosine to find our velocity in the x and our sine to find our velocity in the y. So one of the most important things with vertically launched projectiles, instead of the initial velocity in the y being 0, our displacement in the y will be 0. So our distance in the y will always be 0. Why? Because this thing is going up and it's coming back down. It's landing in the same spot. So our displacement is always 0. And you'll see that in some of the example problems that we work on today. So the steps to solve a full projectile are very similar to the half projectiles, but we just added a few steps. The first thing you always need to do is to draw your triangle. Angle always goes near the x. Then we have our velocity. We need to find our x and y components. Because remember, in projectiles, our x and y's are always separate. Then we're going to solve for x and y using our cosines and our sines. So in this example, to figure out x, I would do 15 cosine 30. To figure out y, I would do 15 sine 30. Then I'm going to get two answers. Now we go into what we have done before. I write down my knowns in the x and my knowns in the y. As a note, my initial velocity in the y is not 0 anymore. It's going to have a number. Remember, I'm launching things at an angle, so I do have an initial velocity in the y. Then we'll keep doing what we'll be doing and determining which equations we'll be using, and then we'll be solving it. So another hint to solve full projectiles is just in the setup. So after we figure out our x velocity and our y velocity using sine and cosine, we need to plug things in. In our x direction, these are still constant. Remember, nothing is affecting our x direction. In the y, we're going to have a number for this. It's not 0 anymore. We're launching it at an angle. Our acceleration is always the same. Now, our displacement in the y is 0. Why? This thing is coming up and it's coming back down to the same place. Okay, so I'm going to set up one of these problems only. The next example, I will actually go through and solve it. All right. So in this problem, a rocket is launched with an initial velocity of 184 meters per second at an angle of 50 degrees. How long is the rocket in the air? How far away does it land? So we're only going to set up, which is what you're going to do in your follow-up questions. All right, let's draw this. So I'm going to first draw my angle. I have 50 degrees here, and I have 184 on my resultant. And I have my x and my y. So my first step is to always solve for x and y. So my velocity, my x, 184 cosine 50 degrees. My velocity in my y, 184 sine 50. So I'm skipping a step here. Instead of writing out cosine 50 degrees equals Vx over 184. I'm not writing that part out. I'm just going straight to writing it out in a way I can solve it. So if you still need to use this part, that's fine. So my answers are 118.3 meters per second and then 140.95 meters per second. Let's do our t-chart in my x and my y direction. So my initial velocity in my y, my x, always the same. So 118, looking for my distance, looking for my time. In my y, before I even get started, my acceleration is negative 9.8. My distance is 0. My velocity initial, remember it's a number now, is that 140. And I'm looking for time. My next step would to be figure out my equations and solve. So now let's actually solve this all the way out. This is a really good example to come back to when we start solving these all the way out in class. So a place kicker kicks a football with a velocity of 20 meters per second at an angle of 153 degrees. How long is the ball in the air? How far away does it land? And how high does it travel? I'm going to solve each of these parts. My first step is to draw out what's going on. Then I'm going to solve for my velocity in my x and my velocity in my y. My work is shown here. Really straightforward. We're following the same steps every single time. Okay, so let's solve for the time first. Let's set up my x and my y. So in my x direction, I have an initial velocity and a final velocity that stays constant. My y direction, before I even get started, negative 9.8 for acceleration, my distance equals 0. I also know my initial velocity, which is 159.7. I am looking for time. All right, so I'm going to use the equation for these variables on this side. D equals 1/2 AT squared plus V0T. Solving these problems are going to be a little bit different this time, so make sure you're really paying attention to the math that I'm going to do here. Let's plug in our numbers. Okay, so as you can see, I have two t's in this problem, t squared and t. Let's take out a t from both of these. Okay, so over here I have t equals 0, and then I can also take this equation, which has t, and set it equal to 0 as well. From here, I'm just solving. Okay, so I bring 4.9t over to the other side, divide, and I get t equals 3.25 seconds. Awesome. All right, so now we're going to focus on our x, and we are going to be solving for how high the ball travels. So let's write in our variables, just worry about them in the x direction right now, or just use the t-chart that you already have. So VI equals 12.04, V final equals 12.04 as well. My time I determined for my previous problem, and I'm looking for my distance. So we'll use the same equation that we have been using for my x side. Remember, I don't have acceleration, so this is really the only problem that I can use. So for my distance, I'm going to get 39.13 meters. And my last part of the problem, how high does it travel? So if it asks how high does it travel, we actually need to set up a new t-chart. I don't need to worry about x because it's just going in the y. I know my initial velocity is 15.97. If it's at the top of the trajectory right here, my velocity final is 0. My acceleration is still negative 9.8, and I am looking for my distance, my height. So sometimes in these problems, you will have to have a second t-chart. But that's really going to depend on what the problem is asking. So let's plug in our numbers. So 0 equals negative 19.6 plus 255. So for my distance, I'm going to get 13.0 meters. All right, so here are your follow-up questions. Answer them to the best of your ability. For 5 and 6, only set it up. Just sketch, solve for the x and y velocities, and do your x and y components. That's what we're going to focus on at first. Make sure you do your follow-up questions, take a picture, and upload it into Google Classroom, or if you're having issues uploading it, just email it to me. Thank you.